Welcome to our group project presentation. We are from Group 3, Section 2 of Geology BFC21303. Today, my name Yong Yu Kin with my group mates Oyame Liu Jiayi, Lim Xiu Tong, and Muhammad Shah Faris. We are going to present you a project which our project title is Foundation on Rock. First of all, what is foundation on rock? A foundation on rock is the foundation that extends all the way down to solid rock such as chalk, clay shales, clay bands, friable sandstone, tuff, or porous limestone. And what needs to be considered to a foundation on rock? It is the rock crushing strength and the bearing pressure, porosity, type of rock, water content in the rock, and etc. This is the few type of example of the rock foundation. Figure 1a is the ideal state of the rock foundation. It is moderately robust, have no fracture, smooth and horizontal, and it has a well-defined bedrock surface. Other than that, figure B to F is a non-ideal state of rock foundation. It decomposes structural limestone, folded rock, weathered rock with or without infill materials, and lastly, it has a fractured rock. In the project we did today, we are going to do an investigation in Kuala Lumpur with the rock foundation. The Kuala Lumpur limestone is a highly crystalline grey cream, thickly bed, variable dolomitic, and cautetic limestone that is estimated to be 1,830 meter thick. So, the detailed site investigation are required to determine the location, distribution, orientation of underground solution channels, cavities, and also the sinkholes in order to avoid future foundation issues.
Hi, my name is Lim Xiu Tong and will present about the literature review of this project. There are three types of the rock foundation, which are spread footings, socketed piers, and the tension foundations. Spread footings is utilized to support the column and walls, then convey the load coming to the structure to the soil below it. It may be circular, square, or rectangular slab of uniform thickness. Its base is wider than a typical load-bearing wall foundation base. Wider bottom disseminates that the burden over a sizable area and adding the stability to the building. The base of the foundation is made by the concrete, reinforced concrete member, and the spread footings are constructed with concrete and steel due to their design. Concrete for the spread footings should be deep enough to resist the punching and direct shear transfer from the column. Tension member structure that produce permanent uplift loads. The support can be provided by the weight of the structure and tied down anchors grouted into the underlying rock. The uplift capacity of an anchor is determined by the shear strength of the rock grout bond and the characteristics of the rock cone that is developed by the anchor. The dimension of this cone is defined by the developed anchor length and the apex angle of the cone. The position of the apex is assumed at the midpoint of the anchor length, and the angles varies about 60 degrees to 120 degrees. 60-degree apex angle is used for the persistent discontinuities parallel to the load direction, while the 120 apex angle will be used in the massive rock. When calculate the uplift capacity, we will assume the cone is separated from the surrounding rock and only the weight of the cone resists the uplift. Socketed piers can be designed to withstand the axial loads, compressive strength, tensile strength, and the lateral forces with minimal displacement. For the loads on individual footings are very high and the accessible bearing surface has inadequate bearing capacity, may be necessary to drill a shaft into the underlying rock and construct a socketed pier. The support provided can comprises the shear strength around the periphery of the drill hole and the end bearing on the bottom of the hole.
Hi, my name is Muhammad Shah Sunata, metric number AF190093. Today I would like to present about the application in the condition of the foundation in limestone area. As we know, foundation is function to transfer the load to the earth. The foundation also can be categorized into two, that is shallow foundation and the deep foundation. There are several problems in acting in the limestone area. There was weathering, staining, erosion, and the crumbling. The picture is the show of the effect of the weather and the crumbling that also produce the sinkhole. So, to solve the problem, we can use some system to overcome it, just like micropile that can reduce extent of cavity probing, ball pile embedded used for the high-rise building, and driving jack-in pile that used for the low-rise building. From the picture, it can show the installation for the three of the system. So, in this topic, we can conclude that the design and the construction foundation in limestone area pose tremendous challenge to the geotechnical engineer. To create a safe and the cost-effective foundation solution, it's necessary to understand the possible issue in the site. Engineer also must planning from the design phase to the construction phase with constant input from the construction team, and the team design essential to ensure the construction in a good performance. That's all. Thank you.
A very good day to you. My name is Ho Yen Mei. Along with my partner Liu Jai, we are going to present the result and discussion of this project. For this project, our case study focused on one of the area in Kuala Lumpur, which located at the Jalan Ipoh and Jalan Maxwell. As you can see here, Jalan Maxwell has been renamed to Jalan Tun Ismail, which is the new name right now. And as you can see here, this is the latest map from Google Map. This is Jalan Ipoh and this is Jalan Tun Ismail, and this is the area for our case study. And for this case study, it also involved with a detailed soil investigation, load-bearing qualities, pile driving criteria, and also building challenge. In this case study, it is to examine the subsurface condition and limestone formation in the area to construct a suitable types of piling foundation. As you can see here, this is the strata of the area of the soil, and also these are the example pictures where we need to find a suitable pile in order to construct in that area. In this subsurface condition, a total of 10 boreholes were drilled at the range of 15.2 to 45.7 meters. And as you see, this figure shows that the generalized of boreholes that is penetrate to the soil in the area. So, in order to penetrate a much harder strata, a standard penetration test were used. This is the figure for the standard penetration test. And once the drilling reached the bedrock, a diamond core drilling was carried out for another 5 meters in order to look for cavities in the bedrock. Lastly, for the selection and construction of pile foundation, a high-yield steel piles with H section were chosen due to its benefit, which is the most cost-effective pile type compared to the rest of the piles, and it is also minimize the excessive installation time and cost. And lastly, it gives no impact on surrounding structure due to its limited soil displacement while driving into the soil. And because of this process, a laser hammer were used during the piling process as well. So that is all from me. Thank you.
Good morning to Dr. Nurul Hidayah. My name is Liu Jai, and today I would like to continue with the part of result and discussion by showing examples of calculating allowable bearing capacities of a wide stripe footings. So I will using these three types of methods, which are building codes, Hope-Brown strength criterions, and Bell solution in calculating the bearing capacity. So for this case, we are going to consider a 2 meter wide stripe footing bearing on the surface of a fair quality limestone in which the average discontinuity spacing is 400 mm and the discontinuity contains some clay. So for this case, the discontinuity may include joints, bedding planes, shear zones, and faults. And this will be the picture of the wide stripe. This is how a limestone looks like, and the table below shows the strength properties of rocks. First is the compressive strength. is shown to be 75 megapascal. Curve strength envelope parameters m equal to 0.128 and s equal to 0.00009, and the rock density is found to be 0.022 meganewton per meter cube, and the correction factor of CF1 and CF2 is equal to 1. First method to determine bearing capacity of foundation on rock is building codes. Table 4.1 shows the building codes for Rochester, New York, and Table 4.2 show the allowable bearing pressures for fresh rocks according to typical building codes. Thus, from these two tables, we can know that the bearing capacity of rock which is moderately strong and has moderate discontinuity spacing is about 1 to 2 megapascal. Next will be Holt-Brown strength criterion, and this is the formula for it to calculate the bearing capacity. So, substitute the value of CF1, parameter S and M, unconfined compressive strength and safety factor equal to 3 into the equation, then we will get the bearing capacity of 1.14 megapascal at last. That method is Bell solution. There are some additional unknowns which need to be determined compared to the previous method, such as B, the footing width, gamma R, the rock density, D, the depth of embankment, C is the mass cohesion, and few more unknowns such as bearing capacity factor, NC, N gamma, and NQ, which we are going to discuss their equation in the next slide. So, these three equations is used to find the bearing capacity factor. Substitute n theta, which is equal to 2.47 into these three equations, then we will get the bearing capacity factor, which is equal to 10.92, 4.01, and 6.10 respectively. Finally, substitute all the unknown that we got previously and we can get the allowable bearing capacity of 2 megapascal for this Bell solution. Therefore, the allowable bearing capacity of a strike footing with width of 2 meters on limestone is about 1 to 2 megapascal based on the value obtained from these three methods. So that's all from me. Thank you.
In conclusion, clay and silty soils will be considered as non-ideal rock type for the rock foundation is because they have porous soils and it is easily expand when wet and shrink a lot when dry. Other than that, smaller particles which able to hold water for longer time. For the ideal rock type, pits and loam is the best choice. Sand and gravel, it is a good choice also because it is bigger in particles and sand does not hold water for a long time. In terms of rock, such as limestone, bedrock, and sand rock, they have extremely high bearing capacity, so it can consider as an ideal rock types. Soil types can have significant impact on foundation repairs and installation project. Hence, knowing the type of soil before starting a project will save time and money for the contractors and other foundation repairs companies because you are able to choose the finest foundation installation solution. Hence, there are few foundation that is suitable for the limestone in Kuala Lumpur, which is driven piles, jack-in piles, boss piles, and we are using micro piles also. That's all from me. Thank you.